Hey, we're live. Okay, it's a chilled Saturday morning. We're gonna continue with iterating over results. Yeah, I think it was the day for yesterday. We were looking at it as well. So we're looking at the Rust language reference, and we're doing this because we want to continue with Rust links, which we started some time back, right? So we basically reading the Rust book and in side by side we're doing Rust links, and part of the required reading or like further reading is boxing errors, which has it which boxing errors, which is I think it's one of the sections inside of error handling in the Rust language reference. So we decided, okay, we just go over the entire chapter, right, and understand about how errors work. So today we're gonna do that, right, learn about iterating over results. If we need to learn about how an API works, we check in the standard documentation for it, right? And maybe try out some code and see, right? So that's the idea here. Okay, so iterating over results. So you can do iter.map operations. So basically, you have an iterator, and then the map might fail, for example, like so, like this example here. It might fail, and there are some strategies, a couple of strategies to deal with this kind of case. Um, okay. So when it fails, you want to be able to deal with it. So one of the ways that so basically map, I mean, what's going on here is that we declare binding numbers, and we say it's of type vector that is of a type unknown type or type that we don't care about, and then we say like strings. We take the string, the vector that we had already, and then um we into iter we create an iterator with the values, right? Um, yeah, and then we map that iterator, basically going through each item of the iterator, going through each of the values that we to do next, right? Here, and then for each value, we would try to um, do a parse to I32 type. So basically, do a conversion, and this parse usually returns a result that is uh, the OK value variant will be I32 or a parsing error, right? And then we want to collect this. Because we provided a type that it should be collected into, this is what the compiler is going to collect this into. So we try to collect this into a vector of types that are unknown here. But the thing is, the first one would fail, right? So basically, let's write this code actually. So um, yeah, I think we can write it here. I'm just gonna get rid of what we have. Um, let me hold on. Okay, wait. I was gonna. Oh, I just want to remove everything here. Let's just get rid of it and then right, right, make it. Yep. But so don't worry about this that I have here in the main method. This is also another way of having your main method. Main method can return a result that returns a unit type in the OK variant or a smart pointer that points to the error, right? So yeah, and for that reason, we have to return OK. I mean, we can return OK unit type. Uh, Same thing as saying function main, like this returning this return a unit type. So it's the same thing, right? So, but I like to do this, and I get a little bit used to this other way of doing it. Yeah. Okay. So now let's let's write that function we just saw now, right? So that we appreciate the reason why we need to be able to, well, let me put this, move it around. Yeah, I mean, like appreciate what we want to do with when the strategies for dealing with failed operations when we iterate over and when we go through an iterator. Yeah, so we have strings, for example, yeah, that are that is a vector that has like tofu, has like 98 and has 100, yeah. And then, 1 second, 1 second, let me just also notify that. 1 second, I'm just sharing this link to going to that to yeah other places. Um, okay, all right. So now let's continue. Let's get back to it. So we have yeah we have this, and then we try to yeah. So we go for this, right? So we can do um let's say let result, for example, be strings, and then we need to we need to convert the values in this vector into an iterator, right? So we can do into iter. So yeah, it creates an iterator from value. Yeah, exactly. So let's create an iterator, and then we can do a map on the values of the iterator. So now we provide a closure here and say that for each string value or string slice value here, we want to do a part. Sorry, I called it S. Yeah, we want to do a parse, and we want to use the turbo feature operator um, to provide the type that should be parsed into, right? Yeah, and then uh, this will be so each value, each item here is going to be parsed. And by the way, at this point, we're going to be getting. I mean, at this point, this will be converted to a result of iter2 or parsing error, right? And then we want to collect this. Yeah. Yep. So now we want to collect this. By the way, I think I need to find a way to format this. I would like it to be not be done on a straight line. I need to figure out how to format my new theme setup. Yeah. Okay, so we want to collect this, but it needs a type annotation. Yeah. So basically, the compiler doesn't know how it should collect this or what it should collect this into. So yeah, two ways we can do that. One way is that we can provide the type here and say it's a vector. But I want to try something now. I want to say why can I not just say iter2 here, right? Why would this not work? It says that value, right? So why would this not work? So this is the error here. This is what we see. The error we see here, this one here. It says that a value of type vec32, i32 cannot be built from an iterator over elements of the trait from iterator. Yeah, that takes a result of i32 and passing there. Uh, so the trait that is not implemented. So the trait is not implemented for that trait implementation. Expected i32. Sorry. So for that trading position, expected I-32 found a result of I-32. Okay, okay. So the only way that this would yes, that makes sense. So I was trying this out, yeah, because I was like, why do we need? I think that makes sense because you want to collect this. You're saying that so we declare we provide that this is a vec of I32, but what is being returned from the map would be result types, right? That's what it will be. It'll be result of I32 and number of partially error, which is exactly what is going to be returned from here. But we are now saying that collect that into this type. So this would not work. The way what would work here would be that we need to say, um, if I say results I32 and parsing error, will this work? A value of I32 cannot, um, a value of type I32 cannot be built. Wait, I32 cannot be built from an iterator. So, and I'm trying to understand what the compiler is saying. It's interesting for me. Um, so the thing is a trait. The trait from which I32 is not implemented for I32 required for. Okay. All right. So anyway, we know what we should do anyway. So I was just trying things out there. Um, if we want this to be collected uh, this way, we can actually say. I mean, we saw that we can say a vector of unknown types, and this will work because you can actually collect that into a vector it's because vector implements. I think we will see that why this works. Um, wait. Okay, so in Rust, why does this um, code work? So let strings be mm, does this work and not uh, I mean I wanted to explain why this will not work. So it's about type inference. Yeah, I think that is the from iterator. Okay. Yeah, I was trying to. Okay, I think we even saw that actually. The from iterator trait in Rust actually that does that one. And the from iterator has a from iter function, yeah, that does that. So it does conversion from an iterator to whatever type that you provide for it. Okay, where T, so from iterator you have so it takes the iter, the iter is of type T, where T uh, implements into iterator an item, and each item is A, yeah, and then you can do the conversion. So by implementing from iterator, you define how it will be created from how a type will be created from an iterator. Okay. If you want to create a collection from the content of an iterator, the iterator collect method is preferred. Um, doesn't the iterator collect method? If you want to create a collection from the content of an iterator. Yeah, but then doesn't this also internally, how does this work internally? The collect method internally, does it not also call the from iter method? However, if you need to specify the container type, okay, if you need to specify the container type from iter method can be more readable than using the turbo fish. Okay, yeah, so yeah, it's just about readability here because do they'll basically do the same. I mean, they would internally would call the from iter, right? This is about um, readability. So if you want to specify the container type, then you'd likely want to do make it explicit by using by doing from iter when you need to specify container type, and doing from iter um, can be more readable than using the turbofish. And this one just means that you would just specify the type. That's it, right? That's all what you need to do. So examples are like so. Okay, I think you're saying that you would then say from iter directly on the type that you want to do this from, okay? Okay, so you're just talking about using the from iter directly, like so. But in any case, if you also specify if you also specify the type, it would internally call we should check I will check that. Hey, Melly Henry. Hello. Great work. Yeah, I'm trying to. Yeah, I'm looking at how this works. Yeah, and why they work differently. You know. Yeah. So more examples of how this would work. Okay, so yeah, so we know that this works using the from iterator trait. Yeah, and I guess we cannot see the from here. We would not see the implementations. But if we go to vec, for example, um, if we go to vec, we would see the section on implementations, right? We should be able to see from iter the trait implementation for this one, right? Um, I don't see it here, but then how? Okay, no, we should be able to see that here because that's the only way that a vector would be able to do the auto collection, right? So if you were trying to collect into a vector from an iterator or whatever, that's the way it would work, right? So um, unless it happens, how does that happen? Oh wait, I think I see. Is this is from? This is from. Okay, from vec. No, that's not it. Oh wait, from iterator, it's generic. Okay, this is it. Actually, yeah, actually generic. Yeah, because you can then it's a vector, right? That can take any type, so it's generic. So the expression is for it to be generic. Yes, and then whatever type you provide. um, the there's already a trait implementation that allows the vector to be able to um, automatically convert whatever iterator you provide into a vector. Yep, that's how it works. Okay, so at least this is so yeah, function from iter is implemented here as we see here. So it creates a value from an iterator. Yeah. Does it show any? Okay, yeah. Okay, so I think that makes sense for how it works. You see it? Um, yeah. Hey, Melly Henry, how is I don't know, are you still there? How is your morning going? Is it going well? Okay, so I think I was asking this example in ChatGPT to see like I mean to see. So I was talking about the yeah, it says about type inference. Yes, we know that. So it says the first case is this. Yes. Um, yeah. So we've seen that this is happening because of from iterator. Yes. So the first case, yeah, this returns a result I32 and parsing error. Yes, we already we know that part. So the iterator inside map has type iterator item result. Yeah, results I32 and parsing error. Now collect needs to know what collection to build, and then we wrote. Okay, I'm gonna, yeah, we wrote. So we wrote vec of type that we don't care about, right? Which lets the compiler deduce this. Yes. Okay, so that's why this didn't work. Yep, I think we did. Wait, what? Where did my code go? Um, okay, I think. Wait. Okay, yeah. So we did we did which so what we said before was that we yeah, come on. So what we said before was we excuse me, we were trying to do a map here. We know that this returns result of yeah, result I32 and parsing error, right? And we wanted to collect this. And then what I was saying before, I was doing this. I was saying, oh, why not vec result? No, I know I didn't say vec. I think what I did, yeah, what I did before was this. I said result I32 and parsing error. But this didn't work, right? So it was complaining that yeah, a value of type iterators cannot be built from the type. So I think I need to do a wait, do yep. Okay, I want to close that. So and then I want to do yeah. Let's see what it's saying clearly. Observe that what it's saying is that a value of type I32 cannot be built from an iterator over elements of type I32. Why? Why is that? The trait from iterator, yeah, uh, of this generic type, which is now I32, is not implemented for I32. But we have the trait is generic, and the trait implementation is also generic. Wait, we saw that. Wait, hold on, where is it? The trait is generic, and the implementation is also generic. So why would this? Yeah, this is generic. It's no, it's generic. So let's see. I don't understand. So it says the trait from iterator uh, as a result AE is implemented for Wait, the trait from iterator result AE is implemented for std. This okay. Wait, okay. Wait, is it implemented for a different type? The trait result AE is implemented for result VE required for result of I32 and passing error to implement. What is okay? Um, wait, I want to see the result type and what whether it has the implementation. So if we go to the result enum, does it have a from iterator? It has into iterator. It also has a from iterator. So you can actually, yeah, so there's a from iterator that goes from AE. I mean that so from iter. So basically you take an iterator of and it returns a result VE. So it takes a result and returns okay, but I guess it's a different type is expecting here. But but I mean, this was what, so for me, to me, I was saying, okay, look, if this is returning a result of I32 and passing error, then maybe we should do that here. But this doesn't work. And I think this is still vaguely unclear why the result type is not able to be converted with the from iterator. But we know that if we do a vec of this, yeah, if I say that the vector contains this, then this would work. Why is that actually? Like, so the vector has, so we know already that vector has the from iterator clearly, and I also feel that result has this. So I think it's about the types, that the types are not, um, I think problem is with the types. I think that's the issue. But let's check. So I want to see what this is saying. Let's continue. So yeah, I say collect needs to know how to build. So we wrote vec in variable type, so the compiler can deduce that this the compiler can deduce this. So we don't even so we can then this will allow us to ignore this to make it like so because the compiler can deduce that. That's what it is, okay? So because and why is that? It's because from iterator, aha, so now this comes to the result thing I was saying. It's because from iterator result I32 passing error for vec of result I32 is implemented. Okay. The reason this works is because from iterator result I32 this for vector of result that is implemented. So this works. Result becomes a vector of that. Um, so the second case, why this second case does not work? We're explicitly asking for a vector of I32, but the iterator produces a result of that type exactly. For collect to work, there would need to be an implementation like this. So implementation over TE. So from iterator, okay, to vec of T, but it doesn't exist. So instead, Standard Library provides this. Mhm. Yeah, so the key is the trait. Let's see collect. an iterator where each item is a result TE into a single result CE, which is very useful for fallible operations. So if you write this, um, yeah, that's not what I'm asking you. But wait, when you say this, when you say this, implementation is generic. So why would it not work? Yeah, blanket implementations, yes. For any type, if you have an iterator that yields T, you can collect it from like in effect, in first example, the iterator yields results, I32 parsing error. So here T, yeah, is this. The blanket version applies, so you get like, okay, yeah, okay, so for the fact that first example, it works like that. Yeah, okay. Why it doesn't work with vec this? You actually ask for a vector of I32, but the iterator does not yield I32. It yields a result of I32. So the blanket implementation would require, okay, the type here is the type, uh, yeah, the type here would, for the first example, would be um, result of I32 and passing terror, right? So that would be the type, and that would work. But why does it work with vec of I32? You ask for vec I32, but the result does not yield I32. It yields this. So the blanket equation for vec t would require t to be that. Okay, okay. I think I've spent some time on that. I think I'm just trying to get it to be clearer, like why that doesn't work. I think it makes sense. Also, what is clearer now is also to see that um this just means that the compiler is able to infer the type. Yeah, it just means that the compiler is able to infer the type there. Yeah, because if we print what we have for result, and format argument must be a string literal. Okay, so basically what you want is like you want you want this, yeah. Um wait. Yeah, okay. So yeah, so we get the first error. So this cannot do the mapping, so we get the error. Actually, no, it's not. We are. By the way, yeah, we're trying to collect everything. So what we get two values, right, inside of this vector. So the vector that has results inside. That's what we have. The vector, and then the result. We have one result, which we have one. So the vector has two result values inside of them. The first one is an error. All right, and we see the error here. The second one is an OK98. Okay. Okay, that's fine. So we got that. So let's continue what we're doing. So that's for iterating over results. So now, what if we wanted to ignore the failed items? Yeah, I think we saw this part, but let's just do it. So I think I know what to do to ignore the failed items. Um, so if we wanted to ignore the items that failed here, so let's say we had like um I don't know, 100 and maybe 20, for example. So ignore the failed items here. We can do a filter. I think we already even saw that, but we can just do a filter, filter map, which would take um filter map which does the filtering, which does the mapping and filtering. So we have to also we have to provide an option. I think it returns let me see again this the what this takes. Filter map. Yeah, it uh yeah, so you can also do like filter and map together. So it would take a, but let's check this. I want to see the filter map is on iterator, yes. It takes a function, yeah. It creates an iterator that both filters and maps, yeah. The return iterator yield only value that are supplied with some value, yeah. Okay. So we basically can provide this closure here and say like um yeah. And then this would return for us a result, of course. Um, but because it needs to also do the filtering, then this needs to remember this returns for us actually an option, yeah, not a result of an option. So and but this right now is a result, so we need to convert this to um an option, right? So that OK converts the result to an option. Yeah, I think this should be okay. Yep, this should be okay because we said that okay, it's already an option. So filter map itself should be able to give us only the sub values, right? So only when it succeeds do we are we going to be able to. I think this should work. Let's see what we get. Come on. Yep, that's fine. That's correct. So we have like where we already filtered out the values where it fails. Okay, so that's um so now we want to collect the failed items with map error. I think we saw this already. I think we already did that before. Um, maybe I want to go over it again. Okay, just to want to collect the failed items map error. So if you want to collect the failed items, I think that was what I had before, but let's just do it just to um, go over this part. So I want to add another item here, and I can say that I want errors here as a maybe as a vector, but it's of course going to have to be mutable. So let's just create that first. I mean, it said it needs type annotation uh, here. I can tell it to that it should infer the type, right? Okay, that doesn't help it. Okay, well then I just wait. Once we have the first item put there, it would be able to infer the type. That's fine. So yeah, but actually it's a vector of like strings, of course. Yeah, but let's see. Um, so we do a filter. So we have an iterator. We do a filter map, which would give us the um, which is so this would parse. If you try to parse this, and if it has this is the result already. Yeah, this is a result, and this is already going to give us the OK values here. So I think this is not exactly what we want. Um, so let me try to write this a different way. I'm actually thinking. I mean, there are multiple ways to write this. One of the first thing that comes to my mind right now is that I can do a match and put that to the arrows, put the arrows there. But I think I want to use the map error function to do that. So basically, why can I do a, wait, hold on. Um, hmm. So we already did a parse here. We already did a parse here. This is already a result for us, right? So I can actually do a map error here, right? Yeah, I can do a map error here. So what I would do is I'm gonna take this result and only touch the error. Yeah, so it will leave the OK intact, right? So I'm gonna say map error, and I'm gonna say hmm, each result, or rather each item. Actually, it's already a parsing error, so it's gonna process the error. So yeah, each error, it should do errors dot. It's a vector, right? So it's yeah, we push the vector. I almost forgot. It's a hash map that you do an insert. Yes. So you push to the vector error. Yeah. Okay. So yeah, we to push this to the vector, we yeah. Wait, hold on. Yeah. Okay. Then we still need to do. I mean, we can still process this further. We still need to process further, right? So again, this is still just a this is still well, it was still in the filter map, so we can do a map, right? So now I can still say, mhm. So now we would have maybe the value. Uh, oh no, no, maybe I think what I want instead is to return now the OK, right? I think I can just already because why can I do OK? Yeah, can do that. I can actually say, yeah, I can say the OK because that is still at that point that is still a result. We only just the mapping there, right? So now I have result here. I have result here, and I can also do a print line and say errors, and I can say the errors. I can print the errors here. Yep, yep, that's it. Okay. All right, so I can also if I didn't want to do so, basically, like if I what if I wanted to know which value, which item of this vector caused the error? Because right now there's no correlation between the both of them. If I wanted to do that, I can create a hash map. Well, actually, I can just change this to a hash map. Um, and say this is a hash map of like string, yeah, or maybe can we do? Yeah, we can do. I guess we can do maybe a reference and the error. Yeah, we can do. I can do an error, right? So I can do like error, uh, error, right? So I can say yeah, and then I can say that this is going to be hash map new. Yeah, I think the other time I was streaming, someone was talking about how that we can also set the length of the hash map that will be created. So we can do that too, right? So instead of, I mean, the initial allocation of the hash map, so can we do a capacity? Can we also specify capacity or when we create it? What do we have on the hash map? Wait, let's go to hash map. Uh, yeah, the methods that we have, we want to create a new hash map. You do new, yes, but I want something with capacity. Excuse me. Um, wait. Methods, new, create an empty hash map with a capacity of 0. So it will not allocate until it's first inserted into. Yes, but I want to be able to. Yes, it's just with capacity. So create an empty hash map with at least a specified capacity. So we know it should not go beyond that, okay? That will be able to hold at least the capacity elements without reallocating. This method is, yeah, so we can do that then. So we can say with capacity of what we want. So I can say with capacity, and I know that my strings at length. Yep, and that will be fine. I mean, mm, expected type found trait. Ooh, what is wrong? What is wrong? What is wrong? Oh yeah. Okay. Yes. So error is a trait. Error is not a type. So we need to provide an actual type there. So one thing we can do is we can say that this is going to be. We can use a smart pointer um and say mm, this, which took care of the problem. Yeah. Or we can say we already know the type of error that we would likely get, and we can say, give me a parsing error. Also takes care of the issue, yeah? Okay. Now uh we can continue. We can now say so we have errors as a yeah, that's already complaining down there, right? Because we don't have it's saying no method push. Yeah, so for this you have to do an insert for a hash map, yeah, and you have to say it has to be key and value, right? So I think what we need is excuse me, error the insert, right? So we need to insert with the key and value here. And now the key is going to be do we have that? Oh no, so we cannot wait, hold on. Hold on. we only at this point we only have um the error here. We don't have the what caused the error. Hmm. Am I correct? Let's see. So we have no, we do actually exactly makes sense. We yeah, I think it was the best way we did it. So we have because we're doing everything right inside of the filter map. So basically we have S is the one that caused it, right? So the key is going to be uh, the value we try to parse, right? And the value would be the error here. Yeah. And I think we probably are missing something here, right? Yep, that's it. So let's run this and see. That's it. So we have the result and we have the errors. So the errors are the egg. One of the first error here is egg, and it couldn't be parsed because we got a parsing error. The kind of error is an invalid digit, and the second error is tofu, and it's by the way, the errors are a hash map. That's why it's like this. Second error is tofu, and it's caused because it's a parsing error, and it's the kind is also invalid digit. Um, yeah. Okay, that's fine. I think we get um how to collect the field items, blah blah blah. I think yeah, this is similar to what we did here. Okay, now let's say we should fill the entire operation with collect. Yeah. So how do we fill the entire operation with collect? So let's see how does collect work in um an iterator. So if you go to an iterator and you go to collect, collect transforms an iterator into a collection. So it takes anything iterable and turns it into a relevant collection. So basically what we can, the basic pattern is that we the basic pattern is that which collect is used is to turn one collection to another. So we take a collection, whatever it is, we call iter on it, right? Do a bunch of transformation, and then we call collect at the end. Collect can also create instances of types that are not typical collections. Um, for example, string can be built from chars, and an iterator of results, the items can be collected into a result of collection. Okay, that's not what's interesting to us right now. So because collect is so general, so it can be used a lot like yeah, it can cause problems with type inference. Yeah, as such, collect is one of the few times you will see the syntax affectionately known as a turbofish. I think we've used it a lot already. This helps the inference algorithm understand specifically which collection you're trying to collect into. Yes, we get that part. But how do you then fail? Uh, how do you fail on the first error, right? How does that? Because collect only cares about what I mean, we can check that, but I want to look at the standard reference and then see what I get. Because collect only cares about what you're collecting into, you can still use the partial type hint with turbofish. Hmm. Yeah, okay. So it only cares about what you're collecting into. Yeah, so you have to use it with several fish. Did they give an example? Oh wait, it's I thought you would put this like on the as a type. Oh, you can actually just say, okay. I mean, this is interesting. Look at what they're collecting into. You can still use it with that. And how would this work? Like, so it's just gonna be a vector. So it's just the type that you're collecting into that matters here. So this would be a vector, yes, but how does okay, so I guess it can infer the other type, right? It can infer the type that's going to be in the vector, I guess. Okay, but anyway, failing on the first operation. I think they didn't say anything. They didn't talk about this here. Yeah, they talk about it. Ha ha ha. Fallibility. But this is try collect, right? Aha, this is it here, actually. Yep. So we're just about to skip it. So if you have a list of results over t type and errors, you can collect to see if any of them failed. I really like looking into the standard reference. I like how they write it. Yeah, it's really one of the best documentation I've read in a very long time. Yeah. So see and fail. So you have like results, and you have a couple of results like okay, error, nope, okay, error bad, and then you create an iterator from the values here, and then you collect. And what that would do is, I mean, you collect that, but you also provide specify the type that should be collected into, which is a result that has a vector of a type that the compiler should you give. I mean, type compiler should try to make the inference there, and the error type is a string reference to a string slice. Okay, and you're just trying to collect that's it vector of that. So it will give us the first error. Yeah, so you have the first error. Hmm. Wait, so result will give us the first error. But if you have result that's okay and okay, and you try to collect it, it gives us a list of answers. So to be a vector that has the values in the okay. Okay, I think that's soft work. That's okay. It's easy to understand what's going on there. So basically, we can apply that to our code here. So yeah, let's clean things up. So now what we want to do is to um, collect. We want to collect or fail on the first error. I think that's what they were saying here, right? Where's that? Here. Get rid of this now. So fail the entire operation with collect. So basically, uh, yeah, this is giving us the background. I'll get to that, but let's see. What is the example they gave here? Okay, it's still this kind of stuff. So to fail on the first error, we don't need this anymore, right? I'm just going to get rid of that. Um, yeah, we also don't need this for that. So let me get rid of this one too. So now what we need to do is, so we have again we have strings, which is a binding that which has values of like a vector, which we initialize to a vector like so, right? And now we create an iterator from those values, and then we call collect on it. We provide the compiler with the type, so it knows what the type to collect into, and try to infer the values that will be there, right? So what would happen is it would fail on the first. If there's an error here, it would fail on the first error. Otherwise, but this would not fail because this is okay, right? It's just print everything for us. That's it. Here, there are no errors here. I don't know if this is a good example. Wait, let's see. Let's first see. Yeah. So everything gets printed for us. But I guess that a good enough example for us. I want to do that example that they had there, which was like a vector of um mm, vector of okay and five, maybe error, actually error variant. So a vector that has result, a vector of result, yes. Um, error of like two, and now okay of like six, maybe. Now this is, I don't want to call this strings, let's call these values. So we will be doing let result be values dot into iter, we get an iterator, and then we do collect. I think this is the simplest example that we can do here. So type annotations, you need a type annotation for this. So yes, I'm gonna prove. I mean, we already know that one, so I can give you this one and say it's a vector. So yeah, so the input is a vector of result. Yeah, and we want you to collect it into a vector of types that you should infer. Yeah, yep. Um, okay. I This is exactly what I, yeah, nice. So we see that it did not um so there is no first failure here, right? Like, so we have a vector of results, but the expectation here is that this would fail on the first error. So why is different? This is what we have. So this is similar to what we have here. Why is this not the same? What's wrong? The only difference here is that they have like what? Okay, and certain values. So if you have a result TE of a type and error, so wait. I guess this is on result, but we have a vector. Wait, but this is a result, okay? But is it is it not the same? What's the difference? Okay, this is a vector, but for us we have, if I get rid of this, then it becomes exactly. So there's no difference, right? But does it depend on the? Oh wait, hold on. I think it's probably about the type that you specify to collect into. Yep. Okay. Yep, it's a type that you it's so and okay. Yeah, exactly. I think this was what was the source of my confusion 2 days ago when I was looking into this because I was like, wait, and I think it's makes more sense when you understand how it works. It's from iterator traits. We will see that next, but let me first look at this. Like you have a vector that has result in it, and then you say you so it's the container type that you want to collect into that determines this. So you want to collect this into a result of vector and whatever, and then you want to it will then tell you what. But if you collect this into a vector, then it would give you the to give you that. Interesting. So let's see why it does that, why that works that way. So as you see, we have the first error here. But if there was no errors, if there were no errors, then we would get we'll get wait, let's see. Actually, that's a good point. Yeah, we have um a result that has yeah, and now you have a result. Okay. Now you're gonna have a result that has yeah, a result that has a vector that has yeah, a result that has a vector of strings. That's it. Yep. Okay. But I want to see, let's look at the language reference and see so how this works. So result implements from iterator. Yes. So the thing exactly. So the thing is on result. It's on result. How will this work with options, right? So let's see this. So wait. Result implement from iterator. Where are you? Where are you? Exit. Iterator. Yes. So it takes each element in the iterator. If it's an error, no further elements are taken. An error is returned. If no error occur, a container with the values of each result is returned. Yes, that is important. So this is on result. So that's it. It's not really just about like any type. It's about result. So that's why vec did not work like that. So that's why on vector it's not wait. I want to see how this is on vector. Vector from iterator will work differently. Exactly, it works differently. So it's about result. Now, what happens with option? How does it work with option type? Option and norm, sorry. Go there and see how from iterator works. So it takes each element in the iterator. If it is none, no further elements are taken, and the none is returned. Should no none occur, a container of type V, option V, containing the values of each option is returned. So it works exactly the same way as with result. So basically, I can say that um, this can be a doesn't have to say vec anyway. It can just be it can be an array that has like some, and it can have like none. Wait, I think you don't have um yeah, exactly. You don't none doesn't have anything there. So yeah. So you have some and none, right? Some five and none, and I want to process this, and I want this to be an option, not a result, an option that has um can I say it's a vector? Okay, yeah, an option that has a vector. Wait, so the option would have, yeah, a vector that contains the values that are there. This should work. No, enum contains enum takes one generic parameter, but two. Oh yeah, that's true because we don't need this. So if I provide this, it would be an option that has a vector of values inside of it. So in this case, we get the first error, which is none. First, um, yeah, none exactly. But if I had like some 20, and that's what we get, an option that has a vector of values based on what they are there in that I inferred. Nice. And this example they have here is also is also the same thing. Like there's also an option of that has vector in it, a vector of U16 values, and then we try to do we get an iterator. Actually, this doesn't create an iterator. It it iterates over the values. Let's go back here and find out. I want to be clear. When uh so giving 5, 6, right? Given this, given the above array or whatever, yeah. Um, when what does iter do different from but into iter? Um, my take is that into iter creates an iterator from the values while iter um iterates over the values. Um, iter returns an iterator over references to the elements. Okay, over references to the elements. What I said was iterates over the values. Okay. That's more technical way to say it, right? So it returns an iterator over references to the elements. Yeah. So each item you get from the iterator is a reference to the string slice. But that's what I said. Come on. Yeah. Okay. So each element you get is a reference to the string slice. Yeah. So just returns an iterator on top of the over the string the array that you provided. But iterator, this one's a bit tricky because I don't care about before that since new version of Rust iterator. Iterator on an actual array consumes the array and yields the owned elements exactly. So basically, each item you get is reference to a string slice, not reference to a reference to a string slice. For example, after this, the array can't be used anymore because it was moved into the iterator. Yes, that's it. Okay. Um, okay, you're asking to contrast this with a vec. For a vec, the story is slightly different. When you do a vec, iter yields a reference to a string slice. So iter is it's going to give you an iterator where each element references the original vector, but iter consumes the vector and yields reference to a string slice. So iter on vec has always given you owned values. Your take was close. Yeah, I know. Iter borrows the collection and uses references. Yeah, into iter consumes and yield owned values. Okay, yeah. So I just wanted to make sure that I was, yeah. Okay, yeah. So this would allow you to be able to use the items again. I guess that's what I'm itching to try this now. But anyway, let's not let's not digress too far. So basically, you're doing you map this and then you do a checked add. It checks if it can do that, and then it and checked add returns an option. Yes. So and then you collect, right? So you collect into an option of this. So where it succeeds, you get sum that is a vector of everything. Yeah. Okay. Okay. So I want to try that example that we just saw. So yep. What was that again? It was a value that is an option of what? Of I think it was U16, whatever. It's now okay. Mismatch types expected option E16 found array. Yeah, okay. I think we can say it's a vec, right? What do you mean, man? What do you mean? Okay, I guess wait, hold on. I don't need it then. Just give me a vector of U16 values. But no, it's not a vector of U16, it's a vector that has some U16 values. Or maybe you don't bother about this actually. Just don't bother. Yeah, it's an option that has okay, so leave it at if an option has not I32. So it's a so this can actually be a vector that has option of U 16 values. Why not? So you expected a struct mm, option of U16 found the array of option of integers. Okay. Found array. Does it help if I tell you that you're a vec? It does. Okay. All right. So so with that one, I can say, yeah, I think what I wanted to try. Excuse me. As I forgot what I was trying before. What I wanted to try is iter and so if I do iter if I iterate over the values here and then I say um collect, yeah, and I say let result be that. Oh wait, I have to specify what it should be collected into actually. So here I can say collect this into an um option that has vectors of 16. Yeah. In fact, I can actually even do a map on this and take each item as we were doing before and say like a dot checked. All right. I can do that. Oh, this is an option. Um, so wait, okay, wait. Anyway, let's just first do this. What I want to do here is to so value of type option accuracy can be built from element of option this. Uh, why? Why can't you do that? It says because the um wait, I have a vector that has options in it, and then I want to collect into an option that has a vector of certain values that you can make your inference from, but you cannot do it. Hmm. And the reason you cannot do this is because you say value of type option of this. So you cannot build this type from an iterator over elements of type reference to uh is it because okay option of U16 values. The trait the trait option U16 is not implemented for option vec. Okay. So from iterator is not implemented. Is the problem that it's a reference? Is that it? What if I did into iter? Would that work? Is it because it's not an own type? Oh shit, it is. Okay. I see. Interesting. Interesting. Mm. Okay, so and here on this one, okay. But anyway, let me print the results first and see, and I'm gonna try the other one again. Like, yeah, okay, so that's fine. However, I can try to do. Let's see. I want to try to do iter. I think. Hmm. So you have a reference to an option of U16 values, and what can I do on this? An option I can do a get on it, but wait, what is, why are they able to use this here? Items are one, two. Oh, okay. Okay, in that case, I see. Okay, so in that case, it's not an option. But in my case, I create an option. It's their case is just a vector. That's it. Okay. Okay, that's it. That's fine. But I think what I wanted to do as well um is to see that I can do so now you cannot, now that you've used values here, you cannot print values again because values has moved, right? So let's try to do that because I think we were checking that. Exactly. Values has moved. But if we were to do and if we were to iterate on it, so let's say this is not a vector of options, but it's just a vector of I16 values that is like 1 and 5. And then I do a vec dot iter, and now I can do a map, and for each value here, I can say I can do a checked add. Okay, all right, I checked sub. Uh, when you do a checked sub, the right hand side is going to check if it's the right hand side of the. And what's the basic usage? You're not showing that. When you do a checked sub, I can just do a 5, right? I don't have to specify the sign, right? Because it's already checked sub, right? So, but I want to collect this into an option because this returns an option, yeah? So I collect it into an option of vectors of that, right? And I can still print values in the end. Yes. So there's a failure because it doesn't work, right? You cannot do that because this is of type U16. You cannot do a subtraction on that. So the result will be none. but we can still print values because we used iter and not. So what we are working on here is the references. So iterator gives it an iterator over the vector. So it's like each element of the iterator is going to be a reference to the backend vector. All right, so I think that's a good place to leave it. Um, I probably will do another stream later. I just need to grab a bite. And then we're going to look at collecting all valid values and failures with partition. Yeah, we'll check this next. I think it's been interesting working with the result and options. And I think after that we'll do this error handling rustlings. Yeah. So yeah. So I plan to have multiple streams next week. Yeah, because I have some time next week. So yeah. All right then. See you. Ciao.